And I hope y'all are enjoying the conference. We're coming up on another break soon, but considering Melissa's talk at last conference, I don't think you're going to want to miss this one. So it was super fun and entertaining and engaging. So please, Melissa, talk about one of my favorite portmanteaus, APIOps.
Thank you, Jennifer. No pressure with that introduction. Huh? Hi, everyone. I'm Melissa. I'm super excited to be here. I don't know about you, but my Christmas countdown always starts off with API Days Paris every year. I'm the field CTO at Kong, and we are the world's most widely used API gateway. Now, there's a trend that I've been seeing recently. I've surveyed hundreds of people, and my data tells me that 80% of API teams are trading off between the delivery speed and quality of their APIs. The approaches that we took in the past to become API driven aren't scaling anymore as our landscapes and as our requirements have changed. And consistency is a huge challenge, as Frank was just talking about. And this session is all about that. I'm essentially taking Frank's talk even further, and we're going to look at how we can automate the API lifecycle with APIOps to give you that consistency, to give you speed and quality at scale. To do this, let me start off by welcoming you to Acme. They're a large bank with a sprawling tech landscape, and the company's been around for several decades. So like most of us, they've got a lot of legacy systems and tools and multiple siloed engineering teams. As part of their digital transformation, they're migrating most of their workloads to the cloud and to Kubernetes, and they're adopting more of a consistent API-driven approach. In fact, the mortgages team has just identified the next API they need to build. Emily's just finished designing it, and she's reviewing the spec with her team. They all agree it looks great, so as per their normal process, she sends it off to the API platform team for review and moves on to her next task. The API platform team owns Acme's API platform as well as the overall architecture, and they host and manage the platform on behalf of the rest of Acme, with the goal of raising the overall engineering standards across the organization. And a group of them meet once a week to go through all the new APIs that have been submitted, and they check them for standards. Sadly, in this case, Emily's spec is not approved. It turns out there's a whole set of standards that Emily just doesn't know about. They're probably documented somewhere, but it's not very well communicated. It's not very frequently updated, and it's definitely not done in a developer-friendly way. So a week after she submits it for review, the platform team reject Emily's spec, and it gets pushed back down to her. Now, this is pretty embarrassing for Emily. She's getting called out in front of her peers for not doing a good enough job. And this is also a huge waste of everyone's time. Emily's going to have to redo her work, and the platform team are doing these reviews manually at scheduled intervals. So there's several days wasted even just waiting for that review. And it's not just Emily and the mortgages team that suffers here. Acme's following best practice, and they're using a single API platform for global discovery and reuse across the business, which means as adoption grows, the platform team needs to support more and more teams across the organization and then get more and more APIs coming in for review on top of all the other work they have to do. The platform team ends up being stretched really thin. So rather than spending enough time fully reviewing every API, they end up having to prioritize. Compliance becomes a nightmare and things start to fall through the cracks, which isn't so good for the operations team, who are responsible for maintaining the overall IT estate. Enough has fallen through the cracks, actually, that there's a lot of errors in production. Nothing is guaranteed to be consistent, and deployments are pretty painful. In fact, they refuse to deploy new code more than once a week because it causes so much instability. Elsewhere in Acme, the mobile team operates a little differently. Their goal is building rich digital experiences for Acme's customers as a reaction to the mobile-only banks that were threatening to displace them. They've been given a lot of freedom so that they can get these applications out as quickly as possible. They're actually about to release their latest open banking app. And this one's a big deal for Acme because it's the first time that they're exposing actual API endpoints to customers. Having seen the delays getting APIs live elsewhere in Acme, the mobile teams decided to do things their own way, and they bypassed the API platform team altogether. But they were in such a hurry to go live on time that they just focused on the implementation code and they missed some API best practices. And this means their APIs are inconsistent. They're hard to find, they're hard to access, and they're hard to use, which puts people off, whether that's internal or external consumers. Their prospects are much more likely to go to one of their fintech competitors who know how to treat APIs as products, because that's what makes an API consumable. Making matters worse is the fact that someone in the mobile team forgot to secure one of his APIs when he published it. This then got exploited, and Acme detected a data breach affecting 15 million customer accounts. Acme started off with all the right intentions, but they've ended up trading off between speed and quality. And this is what I'm hearing time and time again is the biggest pain point right now in API adoption. I'm interested to know, actually, stick it in the chat. Are you having to trade off right now? And is it to prioritize speed or to prioritize quality? This problem is where APIOps comes in. APIOps for API operations. It is the automation of the full API lifecycle. It combines DevOps philosophies when it comes to iterative design and continuous testing with GitOps philosophies in terms of automated declarative deployments. Where before we saw manual, costly, and error-prone activities at Acme, we're now going to automate all of it. Let's see what that actually means. We all know the API lifecycle, I'm sure. This is nothing new. Best practice means that we design an API before we build it. And then once it's deployed, we add governance and operational policies to manage it before making it discoverable to consumers in a portal. Then there's all the ongoing operations, and this lifecycle continues going round until we retire the API. This is no different with APIOps. We're still following best practice, but what you're going to see is that the processes we follow at each step and between each step have changed. So at design time, we use a design environment like Kong's open source Insomnia to easily create the API spec, which is typically a Swagger or OAS document. And we also create a test suite for that spec. And here we should check several things like, are we getting the responses we expect in certain conditions? Now, what's critical here is that the tooling we use at design time gives us instant validation. That's linting of the spec against best practices, the ability to run those tests locally and validate what you're building. As the designer of the API, you need to have self-serve tooling that makes it easy to do the right thing from the beginning. You don't want to end up like Emily. When you've created the spec and validated it locally, you then push it into Git or whichever version control system you use, and you raise a pull request for this new API. And then this triggers a governance checkpoint embedded in our pipeline. Before any time is spent building the API, we need to make sure that what we're going to build follows our company standards and is aligned with everything else in the ecosystem. So we automatically invoke the API tests that we built earlier and any other governance checks that we want to include at this stage of the pipeline, like are we paginating consistently across many APIs? Like before, there's going to be checks that the platform owners will want to do for every API that Emily and the other API designers won't necessarily have awareness of. But unlike before, this is not a manual review. This is now an automatic and therefore instant process. In Kong, we enable this through the open source command line tool INSO. If the spec fails any of those tests, it gets automatically pushed back for more work in the design phase. So Emily doesn't have to sit around waiting for a response from the platform team. She just gets an instant automated notification that something needs to change. And because this is an automated check, embedded in the pipeline and triggered by default when a spec's pushed into Git, it means that there's 100% coverage of these checks for every API that's being designed anywhere in APME. So we're now consistently catching errors as close to the beginning of the pipeline as possible, which means that they are much faster and cheaper to remediate. In fact, it was estimated not that long ago that to find and fix a bug now at design time costs 1% of what it would cost in production. Then when all of the tests have passed, then we have a validated spec, and we can now progress onto the build phase. And here we build our API in the normal best practice way. We use the spec as the contract to tell us what the API needs to do and what the interface needs to look like. And we use the tests as we go to validate that the API we're building meets that spec. As before, when the developer commits their code saying it's ready for deployment, a series of tests are triggered. We automatically execute the tests that we built at design time again to make sure that the API still meets our best practice. These tests are actually our unit tests, and they'll also make sure that the implementation of our API functions how it should according to the contract. There may well be additional tests that we also want to carry out at this stage, still automatically. If any of the tests fail, then we know immediately. So we do not deploy the API, we go back and we make the necessary changes until our implementation's how we need it. And we can keep executing these tests for continuous validation of what we're doing. When those tests then pass, we progress forward to deployment. And now this is where we start to see more of a GitOps approach, because when this round of automated tests has been passed, we then automatically generate the declarative configuration file for this API. And this is one of the central components of GitOps. It's all about declarative rather than imperative ways of managing deployments. This is the modern way of managing infrastructure because it's got so many benefits in terms of deployment speed, auditability, repeatability. These are benefits that we need now when we consider the level of scale and complexity that we have to manage compared to a few years ago. For those that aren't familiar with a declarative approach, let me explain it. It's a lot more streamlined than the traditional approach to CI/CD. So if we're doing things declaratively, we just specify what we want the end result of something to be. Whereas with imperative, we also have to specify how to get that end result. In the context of deployments, if we're implementing CI/CD the imperative way, we have to write a script that orchestrates every deployment step that needs to happen. So call this admin API, extract this value, that token, use it to call this API, add the policies with that API, and so on and so on. This is automated, but this is a pain to first set up, a pain to debug if something goes wrong, and a pain to rewrite if and when one of the underlying admin APIs changes. But if we're doing things the declarative way, we don't need to worry about any of that. We just tell the platform what it needs to look like when that API has been deployed, and the platform itself takes care of how that's achieved. This simplicity is why every modern deployment approach is now declarative. And the same is true in APIOps. Now, the beauty here is that we shouldn't even need to write that declarative config file ourselves. In tools like Kong, we can automatically generate it from the API spec, so we can have it instantly. And because it's generated from the spec, it'll be completely accurate and consistent with the spec so that we know that nothing will be forgotten about, and there's no chance of human error in that deployment process. So that declarative configuration, having been automatically generated as part of the pipeline, instructs the API platform what it needs to look like once that API has been deployed. And the platform goes off and magically configures itself. So we end up with our API registered in the platform and with the various security, governance, and operational plugins for that API configured as well. It's also worth noting here that we store this declarative config file in Git or in version control, along with the spec, the tests, and the implementation of the API. And this means that we have a complete, searchable, and auditable history of every deployment we've made. So if ever there's a problem once we've deployed the API, then we can very easily roll back to a previous state. So it's not just that we've made deployment easier, but rollbacks as well. Of course, once we've deployed the API, we need to validate that it performs how we expect and check that we haven't caused any errors. We're now in an environment where other APIs and code's been deployed, so we need to do some integration testing, security testing, performance testing, whatever's appropriate depending on where you're at in your software development lifecycle. So we'll run that series of release checks before we actually publish this API and make it discoverable. And these checks should also all be automated, orchestrated from your CI tool, although you may want a final sign-off as a manual step before you push that publish button. But when you do, then registering the API in the portal, enabling self-serve access, and adding the spec for that API should be an automated process as well. After all, the only way to ensure that every API is discoverable and documented in the portal is to automate that publishing. Now, what we've built up as we've gone through the API lifecycle is this inventory of assets that enable us to operate this API on an ongoing basis in an almost entirely self-sufficient way. If we need to scale out the API to handle higher throughput, that can be completely automated using the declarative configuration. Since this is version controlled, we'll see a completely repeatable, identical deployment to before. The overall result here, when our API lifecycles follow APIOps, is that the continuous automated testing and deployment means that we catch and resolve errors and deviations from our standards early, speeding up deployment and raising quality and consistency. ACME have just adopted APIOps. And in the mortgages team, Emily's working on another API. As before, she's following best practice by doing this design first. But unlike before, the tool she's using to create her design gives her instant feedback on it. So she can make sure herself that the spec she's building doesn't violate any policies. She skipped out several days of back and forth with the API platform team to get this right. Instead, it now just takes her a few minutes herself. And then once her spec meets standards, she's then got the ability to push it directly into Git so that it triggers the next part of the automated APIOps pipeline. This creates a pull request in Git for the API platform team to then review and decide whether to approve and merge it into the code base or to reject it and send it back to Emily for more work. Life is very different now in the API platform team. They've automated the API review process and they've applied it to every single API coming in for review. So they've got 100% coverage of every quality, security, and compliance check across every single API being built at ACME. Their QA costs have gone way down, and they're no longer the bottleneck for APIs being deployed. If there was a problem in Emily's spec, she wouldn't have to wait for the next scheduled review session because these automated reviews are triggered whenever a new API has been submitted. But this time, there weren't any issues with Emily's spec. The tool she used at design time made it easy for her to do the right thing from the beginning. So the chances of her API meeting standards now is much higher. Once the automated tests have passed, the last step is the automatic generation of the declarative config file from the spec. And this is then added to Git and picked up by the operations team. Not that they really have to do much. The API platform configures itself based on the declarative config. It registers the endpoints and applies and configures all the necessary policies as well. So no more forgetting the security. The platform also automatically makes the endpoint discoverable in Acme's portal. So Emily's API is deployed immediately and smoothly. Deployment's much more likely to go smoothly with APIOps because A, everything has been tested, so the chance of introducing problems is lower, and B, the deployment is completely automated and declarative. In fact, deployments are now so repeatable that the operations team have removed their limit of 1 a week. They're now deploying in a truly continuous fashion, and they can meet the increasing demands as API adoption accelerates across Acme. Of course, there'll still be times when things go wrong. That's unavoidable. But the impact of something going wrong is now much easier to minimize. Since every version of each declarative configuration is in version control, we have a complete history of every deployment. And since these files are all declarative, it's really easy to just revert back to a previous state. The operations team just needs to feed in one of the previous configurations to the platform, and it'll revert itself back. Things are quite different for API consumers now too. Through APIOps, we're ensuring every API is consistently discoverable, secured, documented, and reliable. And this means Acme's portal is now a thing of beauty. It's a catalog of products where each product is a well-designed API. All of this means that Acme can now operate at pace without lowering delivery quality. In fact, they're increasing quality whilst reducing costs, which means that they've got much more resource to innovate than they could before. So they're constantly delivering new capabilities and experiences to their customers. This is the power of APIOps, and it's not just open to companies like Acme. Every single organization can automate the API lifecycle like this. We just saw Frank show how AXA have done that. If you have the right API tooling and the right API first mindset. Thank you very much. And I believe we've still got 1 more minute for questions, I think, Jennifer.
No, that was excellent, as expected, as before. And we all love shiny, shiny cartoons. So it works well. It's for our brains at the end of a set of talks. So it's great. How many companies are at, because even GitOps is still quite nascent. Yes, we should be doing, but a lot of companies aren't. How many companies are actually embracing APIOps?
That's a really good question. More than you think. The term APIOps is fairly new, not something people are familiar with, but every single organization that I speak to about enabling a self-serve developer ecosystem, automated compliance checks, automated linting, every organization I speak to is trying to build this model to the point where many have tried to build custom tooling to enable this workflow. So although there needs to be a greater shift across an engineering group of a DevOps and a GitOps mindset, this goal is something that I see everybody striving to achieve.
Okay. And I have to ask, because I've just been curious, it's a role I've never heard of before. What does a field CTO do?
It's the best job in the world, Jennifer. I get to work with our strategic customers, with our product team, with our customer advisory boards, making sure that the direction that we're going in is really the right long-term direction.
Okay, fair enough. I'm sure hopefully other companies will create that role. I don't hear it often as a name, but it sounds great. Well, thank you so much, Melissa. And for those that don't know, Melissa is very involved in the Women in API community. So in mentoring and speaking up. So it's not just for women, any gender minority and people minoritized by tech in general. So we definitely want to see more of y'all on stage. So if you want to receive more training, more practice, so you feel more comfortable in 2022, I'd like to see a much more diverse speaker list at the next coming API days. They're going to be online for at least the first couple. So it's a great reason to do this, and we're happy to support you however much we can. Yeah. Thank you so much, Melissa.